Very good afternoon to all of you. Am I audible to you? Please reply me. मेरी आवाज आ रही है आप लोगों को? Yes or no? Please reply me. Who is there? Pramodini is saying yes sir. Okay, Shalu, Omkar, they are saying yes sir. Okay, no problem. Aishwarya, Ganesh also saying yes. ठीक है चलो. So welcome back to the chemistry lecture once again after Diwali vacation, after your internal examination also. First, tell me how was your internal examination? Was it easy or was it difficult? Hmm? Tell me about your internal examination. कैसे थे आप लोग? It was easy sir. Pramodini is saying it was easy sir. Okay. चलो so करना है हम लोगों का लेक्चर स्टार्ट. Exam was awesome sir. Shalu is saying exam बढ़िया थी. Okay चलो. So shall I start lecture now? Please tell me. Shall I start lecture? Ganesh is saying yes sir. Okay, no problem. So we'll start the today's lecture. Okay, this is your lecture number 11 of volumetric analysis. Please remember we are talking about the chapter number 2, that is volumetric analysis, and we have finished in the last lecture we have finished neutralization titration. We have also seen some examples how to calculate or how to perform calculations after your practical work or experimental work, that we have seen in the last lecture. Okay, yes or no? Anybody remember this what we have seen? So today we will see our next topic, that is complexometric titration. Today what we will see? We will start our new topic, and the name of that topic is complexometric titration. So what happens in complexometric titration? There is one metal which is present at the center of that complex, and there are different ligands based upon whatever the coordination number. 4, if coordination number is 4, then 4 ligand is surrounded to the metal atom. If coordination number is 6, then 6 ligands are surrounded to the center metal atom. So what happens here? Metal forms a complex with a ligands. Metal form complex with ligand, or metal form complex with uh, hexadentate ligand, or we can say metal form complex with chelating ligand. So this is the basic principle. क्या है principle है? Metal first forms complex with a ligand or chelating ligand, and when these complexometric or complex formation reactions, when this reaction is used in a titration, or when it is used for the purpose of determination of amount or percentage of particular metal from a given sample, then that titration or that method is called as a complexometric method. That titration or that method is called as a complexometric titration. If you see here, see, this is our reaction number 2 or titration number 2, which is called as a complexometric titration. क्या होता है इसमें? What happens in this titration? See carefully or read this carefully. It is a reaction. Complexometric titration, it is nothing but a reaction. Reaction of what? Reaction of metal and reaction of ligands. So this is a reaction between what? This is a reaction between metal plus ligand. Okay? This is a reaction between metal plus ligand. So what happens in this complexometric reaction? Read carefully. Complexation reactions with a metal ion. So metal ion is there, involves the replacement of one or more coordinated solvent molecule by another nucleophilic group. This nucleophilic group is called as a ligand. Please remember this. This nucleophilic group is called as a ligand, and it is denoted by a capital L. It is denoted by a capital L. So this nucleophilic is called as a ligand. Please remember this. So metal ion is there. This metal ion is present with coordinated solvent molecule. For example, if water is there, so water is acting as a solvent molecule, and there is a replacement of this solvent molecule, for example water molecule, by this ligand. So this condition is there, then it is called as a complexometric titration. Then it is called as a complexometric titration. Let us see the reaction. Let us see reaction here. ठीक है, क्या है? So this is your metal ion. M indicates what? M indicates metal, and this H2O, that is water molecule, n number of water molecule. This number of n depends upon the coordination number of that complex. If the coordination number is 4, then this n is equals to 4. If the coordination number is 3, then this n is equal to 3. If the coordination number of that complex is 6, then this n is equals to 6. So this n depends upon the coordination number. So here M indicates what? Metal. M indicates metal. This H2O, they are called as a solvent molecules. They are called as a solvent molecules. And this L, I have told you, this L is called as a nucleophilic group, or in coordination chemistry it is called as a ligand. In coordination chemistry it is called as a ligand. So what happens? There is a replacement of solvent molecule, and solvent molecules here in this case is water. So replacement of one or more water molecule by the nucleophilic group, and nucleophilic group is called as a ligand, which is denoted by a capital L. So what happens if one ligand is there, so only one water molecule will get removed. See here in the product section, or product side, one water molecule has removed, and one ligand is attached to the metal atom. So what will happen here? MH2O n minus 1. So n minus 1 indicates that only one water molecule has removed, and one nucleophilic group, that is ligand group, has attached to the central metal atom. So this reaction is called as a complexometric reaction. This reaction is called as a complexometric reaction. समझ में आ रहा है? This reaction is called as complexometric reaction. And when this reaction, that is complexometric reaction, is used in a titration, when this reaction is used in a titration, then that titration is called as a complexometric titration. ठीक है? All of you understood what is complexometric titration? Yes or no? Please tell me. समझ में आया है आप लोगों को? What is complexometric titration? Tell me. Have you got this or not? Tell me. Complexometric titration. Yes sir. Pramodini is saying yes sir. Anjas is, Chaitanya is also saying they have understood. Amisha, Vidhi, Sandesh. Okay, very good. So you have understood the complexometric titration. Then we will see what is the definition. Sabha, Ajinkya, Omkar. Okay, very good. That means all of you have understood what is complexometric titration, and you are listening me also. Okay, so next we will see the definition. If you have pen notebook, you can write down the definition of complexometric titration, which is very very important. ये exam में पूछा जाता है. Write down the definition of complexometric titration for 2 marks. Okay, so what you have to do? You have to write down the definition of complexometric titration, and you have to write down the example of complexometric titration. Example is very very important. If you write definition plus example, then only you will get the out of mark. If you write only definition, then you will not get out of marks. Okay, so example is also very very important. So first we will see the definition. क्या है definition? Definition is this: a complexation reaction when used in volumetric analysis. So these complexation reactions, ये रिएक्शन आप लोगों को दिख रही है ना, दिस रिएक्शन इज कॉल्ड एज ए कॉम्प्लेक्सोमेट्रिक रिएक्शन और कॉम्प्लेक्सेशन रिएक्शन. हियर कॉम्प्लेक्सेशन ऑफ मेटल विद लिगैंड टेक्स प्लेस, दैट्स व्हाट इज कॉल्ड एज ए कॉम्प्लेक्सोमेट्रिक और कॉम्प्लेक्सेशन रिएक्शंस. एंड व्हेन दिस कॉम्प्लेक्सेशन रिएक्शन इज यूज्ड इन वॉल्यूमेट्रिक एनालिसिस, especially for determining the concentration of individual cations. especially for determining the concentration of individual cation in a mixture, are termed as a complexometric reactions. क्या है definition? For example, when a complexation reactions, that means these metal plus ligand reactions, when it is used in volumetric reaction, and what is the purpose of using it? What is the purpose of using it? To find out or to determine the concentration of individual cation, or to find out the percentage of metal cation present in a mixture. Then that reaction or that titration is called as a complexometric titration. Okay, understood? What is complexometric titration? When a complexation reaction is used in volumetric analysis, when complexation reaction is used in volumetric analysis, and the purpose of using it, what is the purpose of using it? Yes, can anybody tell me what is the purpose of using complexation reaction in volumetric analysis? क्या पर्पस होता है? What is the purpose of using a complexation reaction in volumetric analysis? आपके स्क्रीन पे है, you have to just read and answer me. What is the purpose? What is the purpose? Yes, Pramodini, Ganesh, Sabha, where are you? What is the purpose of complexation reaction in volumetric analysis? Please tell me. The purpose is here concentration of individual atom. Correct. Omkar is saying what is the purpose? To determine the concentration. What is the purpose? Very simple. To determine the concentration, to determine the amount, or to determine the percentage of individual cation in a mixture. For example, if there is a mixture of different cation. For example, calcium is there, manganese is there, iron is there, and we have to find out the concentration of only calcium or magnesium from the mixture. Then you have to use this complexometric titration. Then you have to titrate that mixture with EDTA. Then you can EDTA is specifically, it is used specifically for calcium and magnesium cation. Please remember this. So this is the complexometric titration. We have seen the introduction, reaction, and definition of complexometric titration. Then we will go to the next point. Okay, sure. So we'll go to the next one. Ganesh saying to determine the concentration. Correct. To determine the concentration of metal cation. That is the purpose of complexation reactions we are using in a volumetric analysis. Okay, chalo. Then we will see the next one. EDTA as a complexing agent. You know EDTA now. Have you heard this word EDTA? किसने किसने ये word सुना है? EDTA. I think you have used this EDTA while performing practical. One experiment was there to find out the hardness of water. Yes, Sabha is saying yes, sir. To find out the hardness of water by titrating with EDTA method. Okay. So what is this EDTA, or what is the long form of EDTA? Can anybody know? है किसी को पता? Long form of EDTA. What is the long form of EDTA? And this EDTA is very good complexing agent. In many complexometric titration, EDTA is used. So you should know the long form of EDTA. Long form of EDTA is ethylene diamine tetraacetic acid. Correct. The long form of EDTA is what? Ethylene diamine tetraacetic acid. Correct. Chaitanya, Santosh, Omkar, Sabha. So what is the structure of EDTA? See, this is the structure of EDTA. See the structure of EDTA आपके स्क्रीन पे. EDTA long form is ethylene diamine tetraacetic acid. नूतन is saying good afternoon sir. नूतन ने late join किया है मेरा lecture. No problem. चलो. So this is the structure of EDTA. बहुत बड़ा और थोड़ा सा बल्कि स्ट्रक्चर है. तो क्या है? So we have seen the long form of EDTA. ठीक है, आप लोगों ने देखा है. Now what is the E stands for? E stands for ethylene, and this CH2 unit is called as ethylene. This CH2 single bond CH2, this unit is called as a ethylene. This unit is called as a ethylene. Then D is for diamine. So one amine is here and second amine is here, so two amines, that means diamines. So EDT हो गया, this nitrogen is there, this nitrogen is there, so it is a diamine. So E का हो गया ethylene, D का diamine, then tetraacetic acid. Tetra means four. Tetra means what? Tetra means four. So four acetic acid groups. So this here, this is first acetic acid group, this is second acetic acid group, then this is third acetic acid group, and this is fourth acetic acid group. That means tetraacetic acid. ठीक है? Have you understood the meaning of EDTA? Ethylene diamine tetraacetic acid. This CH2 unit is called as ethylene. This nitrogen, they are amines. Two nitrogens are there. That's why it is diamine. Then tetraacetic acid, and tetra means four. So there are four acetic acid group. This is first acetate group. Then this is second acetate group. This is third, and this one is fourth acetate group. So if you see here, there are four acetate groups are there. There are four acetate group. That means this EDTA complex is acting as a tetrabasic acid. This EDTA is acting as a tetrabasic acid. Tetrabasic acid means what? It can reacts with four molecules of base. It can react with four molecules of base. So it is called as a tetrabasic acid. So it is called as a tetrabasic acid. So if you see here, there are four acetate group, and this four acetate group or acetic acid group, they can gives H plus ions to the solution. So this total four H plus ions are released by one molecule of EDTA. 4 H plus ions are released by one molecules of EDTA. So there are four ionization constants. So there are four ionization constants. First is related to this group, or maybe it is second is related to this, or this one is third, and this is four. So there are four ionization constant. So क्या है four ionization constant? See आपके screen पे. So there are four ionization constant. So there are four pKa values. There are four pKa values: pKa1, pKa2, pKa3, and pKa4. क्या है? Why four pKa values are there? Because there are this EDTA can give 4 H plus ions in the solution. So this pKa1, if you see the value, pKa1 is 2.0, pKa2 is 2.67, pKa3 is 6.16, and pKa4 is 10.26. So if you see, or if you compare this pKa3 and pKa4, they are much higher than pKa1 and pKa2. So that means what? This pKa3 and pKa4 values, these two H plus or these two acetate group, they can act as a strong acid. They can act as a strong acid. They can act as a strong acid because what? Because of their pKa values are high as compared to pKa1, that is 2, and pKa2, that is 2.67. So these pKa3 and pKa4, they behaves as a strong acid. This behaves as a strong acid. And while out of these four acetate group, please remember this, out of these four acetate group, two acetate groups, they can act as a strong acid, and two acetate group, they act as a weak acid. Based on this pK value, we can say that what we can say that out of these four acetate group, two acetate ions or two acetate they can act as a strong acid, while two acetate group, they can act as a weak acid. ठीक है? Understood why there is four ionization constant? Because of there are, why there is four pKa values? Because there are four acetate group is present in EDTA molecule. Okay, so next, so this difference in ionization constant. So see here, pKa values are different. That means there is a difference in ionization constant. pKa1 and pKa2, they are almost same, and pKa3 and pKa4. So there is lot of difference between these two value and these two value, and this difference in ionization constant, please remember this, or please understood this, listen carefully. This difference in ionization constant leads to large difference in stepwise formation constant. What happens? Because of this difference in ionization constant, which leads to large difference in stepwise formation constant. So there are stepwise formation constant because of all these four acetate groups. They does not use H plus ions in the solution in a one step. So they removes or they releases H plus ion in stepwise manner. So due to this difference in ionization constant, there is a large difference in stepwise formation constant also. Okay. Okay, then if you see the metal complex or metal chelate of EDTA, this group is called as a EDTA, and at the center M is there. At this center M is there, and this M is indicates what? This M indicates metal. So this metal forms six coordinate bond. Metal forms six coordinate bond. Okay, so there are six coordinate bonds are present. So how many? Four oxygen molecules and two nitrogen molecules. So total six coordinate total six coordinate bonds are present. And if you see, metal is only one and ligand is also only one. So the stoichiometric ratio of this complex is 1:1. If you see ligand to metal ratio, if you see the ligand to metal ratio, so here only one ligand is present. See there, all this structure belongs to the EDTA. ये पूरा का पूरा स्ट्रक्चर किसका है? एक ही मॉलिक्यूल का है. EDTA का एक ही मॉलिक्यूल प्रेजेंट है इसमें. So ठीक है. So ligand is one, and if you see metal is also one. So ligand to metal ratio in this complex is 1:1. Please remember this. Ligand to metal ratio in metal chelate when EDTA is present is 1:1. ठीक है. Understood? Understood this? Yes or no? समजले का हे सगळ्यांना? Yes or no? Please tell me. Have you understood this or not? Then only we will go to the next point. Then only, okay, Pramodini, Ganesh, Vaibhav, they are saying yes sir. Okay, chalo. रुपेश कुमार, चैतन्य सिंह हो सर. चलो चैतन्यला पण समजलेलं आहे, चांगली गोष्ट आहे. ठीक आहे. सो विल गो टू द आकांक्षा, संदेश, अजिंक्य, संतोष, वैभव, श्रुती, Shalu Sabha. Very good. Chalo. So that means you have understood. The ligand to metal ratio is 1:1. If you see here, there are four oxygen atom which donates a pair of electron to the nitrogen atom, and there are two nitrogen atom. They can donate a lone pair of electron to the central metal ion and forms total six coordinate bond. Six coordinate bond means the coordination number of this metal complex is 6. Coordination number of this metal complex is 6. Okay, okay, chalo. Then we will go to the next point. We will see the titration curve. We have seen the titration curve for all the neutralization titration. हम लोगों ने देखी थी ना titration curve. What is the titration curve? Titration curve is nothing but the change in pH or change in concentration of H plus ions versus ml of titrant added. Versus ml of titrant added. So the graph or plot of pH versus ml of titrant added, that graph or plot is called as a titration curve. So here also we will see the titration curve. Now here some difference is there जो कि हम लोगों ने न्यूट्रलाइजेशन टाइट्रेशन में देखा है ना, थोड़ा सा अलग है. इफ यू सी द y axis, this axis is called as a y axis. Please remember this. This axis is called as a y axis and this axis is called as a x axis. Now on y axis pm is there. On y axis pm is written, while in case of neutralization reaction आपको अगर याद होगा तो वहां पे क्या था? वहां पे था pH. क्या था वहां पे? pH. And here in the titration curve for complexometric titration, pm is there. We will see what is the meaning of pm. Don't worry about that. And on the x-axis 0.0 molar EDTA in ml is there. On the x-axis 0.0 molar EDTA ml is there. Okay, so we'll see what is the pm. We'll see what is the pm. What is the pm? See here आपके screen पे pm means what? pm is nothing but the negative log of free metal ion concentration. Pm is nothing but the negative log of free metal ion. So here M is what? M indicates the concentration of free metal ion. M is what? M is stands for concentration of free metal ion. P is nothing but the negative log. P is nothing but the negative logarithm. So mathematically we can describe Pm is nothing but the negative log of free metal ion concentration. So mathematically you can write that sentence in the equation. So Pm is equal to negative log of concentration of metal ion. So what is Pm? What is Pm? Pm is nothing but the negative log of free metal ion concentration. Okay, understood what is Pm and what is the equation of Pm? Pm is nothing but the negative log of metal ion concentration. Okay, chalo. Then the metal ion indicator, the metal ion sensitive indicator is used to detect the changes of Pm. So here pH is not we are not detecting, or we are not monitoring the pH, we are not monitoring the concentration of H plus ion. So here normal indicators are not used. Those indicator we have used in neutralization titration, that indicator is not used in case of complexometric titration. Please remember this. Because of what? Because whatever the neutralization titration indicator they work, or their working is based on change in pH. Their working is based on change in pH, or their working is based on change in H plus ion concentration. But here no pH is there, no change in H plus ion concentration is there. So here metal ion sensitive indicators are used. क्या क्या है यहाँ पे? In this case metal ion sensitive indicator is used to detect the changes of concentration of pH or changes of concentration of free metal ion. So which metal ion sensor indicators are used? For example EBT. For example, see here EBT, it is called as a iriochrome black tea indicator. So this indicator is used when EDTA is used as a complexometric agent. Iriochrome black tea. Then second indicator is solochrome black tea indicator. It is also called as SBT. Solochrome black tea indicator. It is also called as a SBT. And pattern and reader indicator. And pattern and reader indicator. So indicators are different than the neutralization reaction. Please remember this. Understood up to this? समझ में आया आप लोगों को यहाँ तक? Normal indicators which we have used in case of neutralization reaction, that indicators are not used here. Here metal ion sensitive indicators are used. Please remember this. Which indicators are used? Metal ion sensitive indicators are used. For example, iriochrome black tea, solochrome black tea, and pattern and reader. EBT, SBT, and pattern and reader indicators are used. Okay? Okay, chalo. Then the next, magnesium EDTA complex. Next point is magnesium EDTA complex. This is very popular, very well known example of complexometric titration. Which example? Magnesium EDTA complex. ये बहुत ही पॉपुलर एग्जांपल है, बहुत ही फेमस एग्जांपल है मैग्नीशियम EDTA टाइट्रेशन. ठीक है. सो क्या होता है इन दिस टाइट्रेशन और इन दिस कॉम्प्लेक्स फॉर्मेशन रिएक्शंस? फर्स्ट there is a complex of metal. This M indicates what? This M indicates metal. Please remember this. This M indicates metal. M is stands for metal, and this ion is stands for indicator. This ion is stands for indicator. So at the starting there is a metal indicator complex. At the starting there is metal indicator complex is present. At the starting metal indicator complex is present, and the color of this metal indicator complex is red. Color of this metal indicator complex is red, and we are titrating, or we are adding from burette EDTA. हम लोग क्या कर रहे हैं? EDTA उस कॉम्प्लेक्स में जो कि हमने बीकर में लिया हुआ है, सॉरी कोनिकल फ्लास्क में लिया हुआ है. मेटल इंडिकेटर कॉम्प्लेक्स वी हैव टेकन दैट इन कोनिकल फ्लास्क, and the color of that solution is red because metal indicator complex or magnesium indicator complex is red color complex. So the color of your solution which is present in conical flask is red, and we are adding EDTA from the burette by dropwise. So what happens, this metal indicator complex get breaks, this metal indicator complex will get break, and metal EDTA complex will get formed. So this is metal EDTA complex, this metal EDTA complex, and this indicator becomes free, this indicator becomes free, and this indicator has a blue color, this indicator has a blue color, this indicator has a blue color. Okay, have you understood this formation of magnesium EDTA complex? आप लोगों को समझ में आया मैग्नीशियम EDTA complex? Yes or no? Please tell me. Have you understood this magnesium EDTA complex or not? Tell me. First, in your conical class, Pramodini is saying yes sir. करेक्ट, वेरी गुड, अच्छी बात है प्रमोदिनी, चैतन्य, ठीक है चलो. फर्स्ट, in your conical flask metal indicator complex is there and the color of that solution is red because metal indicator complex has a color red, and from the burette we are adding EDTA dropwise, and this metal indicator complex will get break and metal EDTA complex will get formed. So now after the completion or after the end of titration, your indicator becomes free and the color of that indicator is blue. Now everyone is saying yes sir. ठीक है, अब सब लोगों को समझ में आया, सबा, अजिंक्य, प्राची. Now everyone is saying yes sir. Now you have to tell me the end point of this titration. Now you people tell me, जिसने किसी ने भी yes sir बोला है ना, now tell me the end point of this titration. What is the end point of this titration? End point of this titration, you have to tell me. Rajendra, Sandesh, Vaibhav, Pramodini. Correct. Very good, Pramodini. The end point of the titration is red to blue. Very good. Very, 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 very good. The end point of the titration is what? The end point of the titration is red to blue. End point of the titration is red to blue. Correct. Very good. So this is the end point of your titration. Okay. So you have understood the magnesium EDTA complex. So during the titration, now see here, during the titration a buffer that is NH4Cl and NH4 is added to create pH between 7 to 11. During the titration you have to maintain the pH. This is the very, very important condition. During the titration you have to maintain the pH. And how will you maintain the pH? The pH you have to maintain between 7 to 8. The pH you have to maintain between 7 to 11. And how will you maintain this pH? By adding a buffer. Very simple. How will you maintain? By adding a buffer. And which buffer you have to use? You have to use NH4Cl and NH4OH. This buffer you have to use. This buffer maintains the pH in between 7 to 11, and at this pH. This pH is 7 to 11 pH means it is basic pH, correct? So basic buffer you have to use. So this is basic pH. So to maintain this basic pH you have to use a basic buffer, that is NH4Cl and NH4OH, and at this basic pH, metal indicator complex shows red color. I have told you earlier. At this pH metal indicator complex shows a red color, and after the complex formation indicator becomes free, that also I have told you, and shows a blue color, So at the starting, in your conical flask you will have a red color solution. At the starting the color of your solution is red color solution, and after the titration the color of your solution will become blue. That means the end point of the titration is red to blue. That means the end point of the titration is red to blue. Okay? And the amount of magnesium can be calculated by using a relation. So main purpose is what? Main purpose of this titration is what? You have to find out the amount of magnesium. But you have to find out the amount of the magnesium, concentration of magnesium, or percentage of magnesium. How will you calculate? So to calculate that amount, that percentage or that concentration, you have to use this relation. This relation is very very important relation. Please write down this relation. अगर आपके पास notebook है तो write down. This is very very important. बहुत ही 3-star equation है. कौन सा equation है? This equation is called as a 3-star equation. बहुत ही important है. By using this equation, you can calculate the amount of magnesium present in a given sample. By using this equation, you can calculate the percentage, you can calculate the concentration, you can calculate the amount of magnesium given in a uh, given sample. What is that equation? This equation, 1 ml 0.1 molar EDTA corresponds to 2.432 milligram of magnesium. This is the equation. 1 ml 0.1 molar EDTA corresponds to 2.432 milligram of magnesium. Write down this equation, which is very very important. This equation you will need while solving the problem. This equation you will need while solving the problem. ठीक है, लिख लिया सब लोगों ने? Yes or no? लिख लिया कि नहीं लिख लिया? The amount of magnesium can be calculated by using the following equation, and then equation is nothing but 1 ml 0.1 molar EDTA corresponds to 2.432 gram of milligram of magnesium. Okay. Vaibhav is saying yes sir, Ganesh is also yes sir. Okay, chalo, no problem. So we'll go to the next point now. Then the next point is types of EDTA titration. So there are two types of EDTA. EDTA titration के कितने types है? There are two types of EDTA titrations. Which two types are there? That we will see. That we will see the which two types are there, or when to use a particular type. कौन सा type कब use करना है? That also we will see. ठीक है? So the types of EDTA titration. First titration is called as a direct titration. First titration is called as a direct titration. Direct titration means we can directly titrate metal with EDTA. The name itself indicate that we can directly titrate the metal with EDTA. So for this titration, what you have to do? You have to use a buffer solution of pH 10. What you have to do? You have to use a buffer solution of pH 10. So in this case, pH 10 means you have to use which buffer? pH 10 means which buffer you have to use? Basic buffer we have to use. Okay? Yes or no? pH 10 means basic buffer you have to use. So use a buffer solution of pH 10, or you can prepare a buffer solution of metal having a pH 10 by using a suitable buffer. First you have to prepare a buffer solution of metal which is having a pH 10. Then this metal solution is directly titrate with standard EDTA solution. Then you can titrate this buffer metal solution, or this metal solution in presence of buffer which is having pH 10 directly with standard EDTA solution. Directly with standard EDTA solution, and by knowing the value of endpoint, you can find out the percentage or amount of magnesium present in the given sample by using that equation that we have seen. So this is the first type. कौन सा type है? First type. The first type is direct titration. As name itself indicate, it's a direct titration. That means you can use directly, or you can titrate directly metal with EDTA. ठीक है? But only condition is you have to maintain the pH. But the only condition is what? You have to maintain the pH, and for that you have to use a basic buffer. For that you have to use basic buffer which can maintain a pH 10. ठीक है? Understood? This is the first titration, that is direct titration. Then second titration is back titration. Second titration is what? Back titration. Now when this method is used, this method is used when metal forms a precipitate with EDTA. So there are some metals which forms a precipitate with EDTA. So in case of that metals, you have to use back titration. So those metal which forms a precipitate with EDTA, for that metals don't use direct titration method. For that metal don't use direct titration method. In that case you have to use back titration method. किसके लिए? जो metals EDTA के साथ प्रेसिपिटेट फॉर्म करते हैं उसके लिए। इन एंड सेकंड क्राइटेरिया इज व्हाट, इफ देयर इज नो सुटेबल इंडिकेटर इज अवेलेबल। अगर सुटेबल इंडिकेटर अवेलेबल नहीं है तभी भी आप लोगों को क्या करना है, आप लोगों को बैक टाइट्रेशन यूज करना है। अगर आपके पास सुटेबल इंडिकेटर है देन यू कैन गो फॉर अ डायरेक्ट टाइट्रेशन, इफ देयर इज नो सुटेबल इंडिकेटर देन you have to use back titration method. So in this method metal solution is not directly titrated with standard EDTA solution. क्या करते हैं in this method में, metal is does not titrated directly with standard EDTA solution. So indirect titration is there. First you have to run blank and then back, and then you have to take a difference, and then by knowing the difference you can find out the percentage of that particular metal present in given sample. ठीक है, understood? Understood, yes or no? समझ में आए? टू टाइप्स ऑफ EDTA टाइट्रेशन। यस सर, ठीक है। सो वी विल स्टॉप हियर, इफ यू हैव एनी प्रॉब्लम एनी डाउट यू कैन आस्क, ठीक है ना? I will give you 5 minutes for that. If you have any problem, any doubt, you can ask me. Otherwise, we will stop. After your doubt or problem, I will active the link for your attendance. ठीक है? जिस किसके भी नाम उस अटेंडेंस शीट में नहीं है वो लोग क्या करोगे, आपको at the end you have to write your name and then you have to write present or absent, ठीक है? अगर जिसके नाम नहीं है उसके लिए, जिसके नाम है वो डायरेक्टली प्रेजेंट और absent लिख सकते हैं, ठीक है? ओके चलो, ठीक है। Any problem, any doubt, you can ask me. I have activated the link for your attendance. No problem. Shall I stop here? Tell me. No problem. Shall I stop here now? Yes or no? Yes, Ganesh, Pramodini Singh, yes sir. Okay. So chalo, bye bye, take care. Rahul is also saying yes sir. Please write your attendance. जिसके किसके भी नाम नहीं है वो लोग अपना नाम नीचे लिख के प्रेजेंट लिख दो, ठीक है? चलो, सो बाय बाय, टेक केयर, हैव अ गुड डे।